Okay, this is definitely a difficult one. It's to help you practice factoring. There's gonna be one question like this on the exam, but it's not gonna have a number in front of the x squared. It's just gonna be more of an x squared one, so that it'll be faster to get it from trinomial into two binomials. That's obviously the hardest part. After that, so first what we're gonna do is we're going to change it from the division of two fractions into multiplication, and the way you do that is you flip your second fraction over and then turn it from division into multiplication. So we'll do that, and then we'll factor each of the trinomials, and then we'll just cancel out binomials that are common to both the numerator and the denominator. All right. There's a lot of this practice throughout the course, so don't worry if this is too much. Don't worry. Okay, so this is what it looks like instead of a fraction divided by another fraction. We have a fraction multiplied by a fraction. We know, so what I did was I flipped this one. We know that multiplication of a fraction just means we multiply straight across. So you could even just put these in parentheses and extend that line and make it one big fraction. All of this is being multiplied by all of this in the top, and then on the bottom, all of this is being multiplied by all of this. Instead, we're not gonna do that right now. What I'm gonna do is I'm gonna try to factor the 4x squared minus 13x minus 12. You can start wherever you want. I'm gonna start with the first one. First thing you do is make sure you can't take 4x squared, negative 13x, and negative 12 and take anything out. Like you divide 4x and negative 12 by 4, but 13 you can't divide out. So in that case, here we have, right, we're going into ax squared plus bx plus c format. So when I say a, I mean your first number. When I say b, I mean your second number. When I say c, I mean your third number. What I want to find is a number that, or sorry, two numbers that when I multiply them together, they will equal a times c. And when I add them together, it will equal b. Okay. A in this case is 4, so we're going to multiply to equal 4 times negative 12, and make sure to include the negative. I don't even know what 4 times 12 is. Negative 48. So we want two numbers that multiply to negative 48 and then add to negative 13. Okay. If they're being multiplied to a negative number, that means I want one number to be positive and one number of my factors to be negative. If it's adding to a negative number, I want my bigger of the two to be the negative number. I like to start with just 1. So we have 1 and negative 48, right? If I divide it by 2, what do I get? Negative 24. If I get 3, 40 divided by 3, 16. And you can be looking at each of these and saying, if I combine those, do I get negative 13? I do. All right, so you can stop already. 3 minus 16, or 3 plus negative 16, will give me that negative 13, and 3 times negative 16 will give me the negative 48. Now what I want to do, take that same, so we started with 4x squared minus 13x minus 12. I'm going to keep the 4x squared, I'm going to keep the a, I'm going to keep the c. So this is, sorry, it's been a couple of days. Okay, I wanted to say it, but I didn't want to say it about it. This is factoring by grouping. So we're going to make groups. If this was just c, then you could go straight into the x plus 3x minus 16, right? But we can't. So instead you're going to group them. I'm going to put my 16 with my 4, but it really doesn't matter. You'll get the right answer either way. So negative 16x plus 3x instead of the negative 13x. You'll see that when you combine those, right, you still get a negative 13, but now I can factor this. So 4x squared minus 16x, I can divide out a 4x for both of those. So this one becomes 4x times 4x squared divided by 4x is just x, negative 16x divided by 4x is negative 4. And then over here we have 3x minus 12. We can divide both of those by 3. That's a positive, so we want that term to be positive, so plus 3. 3x divided by 3 is just x, negative 12 divided by 3 is negative 4. Now, The factored by grouping, we have a common binomial to both of these, right? So in the end, what I have is the x minus 4 factored out. And my remainder is 4x plus 3. Okay, so 4x squared minus 13x minus 12 becomes x minus 4 times 4x minus 3. Moving on to 5x squared minus 7x minus 6. What's a little bit easy. Now we've got 5x squared minus 7x minus 6. Not better than that. Can't, oops, sorry, couldn't even see that. Can't divide anything out of that, right? No common denominator. So we want two terms that multiply to equal a times c, 5 times negative 6. So they should multiply to equal negative 30, and they should add to equal negative 7. I like to start at 1. Bigger term, 1 going to be negative, 1 going to be positive. Bigger term is going to be negative. This would be 1 and negative 30, 2 and negative 15, 3 and negative 10. Oh, that looks like it works, right? When I multiply 3 times negative 10, I get negative 30. When I add 3 plus negative 10, I get negative 7. So keep the 5x squared, keep the a, keep the c, negative 6, and then that negative 7 becomes a 3 and a negative 10. It looks like the negative 10 with the 5 will be easier to make a factor of, and then a 3. And remember, those two get x's. So negative 7x becomes, I just spread it out, a negative 10x plus 3x. Negative 10 plus 3 is still negative 7. So negative 7x is the same as negative 10x plus 3x. Just go ahead and do the factoring now. So we've made it into a group. Now we're going to factor out a number. 5x squared and negative 10x. You can factor out a 5x if you look a lot like the previous one. So we have 5x. 5x squared divided by 5x is just x. Negative 10x divided by 5x is negative 2. And then over here, positive 3 and negative 6. I want to keep it positive. That's a positive. So I'm going to just say it's 3 plus 3. 3x divided by 3 is just x. Negative 6 divided by 3 is negative 2. So it's a good sign if you have the same factor pair, right? So I'm going to factor, or sorry, the same binomial. I'm going to factor out that binomial because it's the same to both of them. So 5x squared minus 7x minus 6 becomes x minus 2 times 5x plus 3. And it's just factoring by grouping. Okay, so that was the top one. That was the top one. Now we have the bottom one. X minus 2 times 5x plus 3. And again, I said you can't just kind of like make that one long line. So I think I'm going to do that, and we're going to go on to the 5x squared plus 23x plus 12. And I'm just going to put it right next to these two because they already will have parentheses. So it just means this times whatever those two factors are. Figure that out. So we have 5x squared plus 23x plus 12. Can't divide anything out of that. So I want two numbers that multiply to equal 5 times 12. Multiply to equal 5 times 12. 60. So it should multiply to 60, but add to 23. Okay. Okay. That's positive and that's positive. So I'm assuming it's only positive factors of 60. 1 and 60, 2 and 30, 3 and 20. Oh, yay. That's good, right? 3 and 20. If I multiply 3 and 20, I get 60. If I add 3 and 20, I get 23. So keep the A, keep the 5x squared, keep the C, keep the 12. And then we have a 3 and a 20. I'm going to say 5x squared plus 20x plus 3x because 3 and 12 are common factors and 5 and 4. 20 and 12 also have common factors, so if you put the 3x here, it will be fine. It'll work. All right, what can I divide out of 5x squared and 20x? You can divide out with 5x. Now I have a 5x times x plus 4. Over here, 3x and 12, I can divide out by 3. And I get plus 3 times x plus 4. X plus 4, x plus 4. All right, so that was 5x squared plus 23, x plus 12, and now it is x plus 4 times 5x plus 3. And again, I'm just going to put them right up here. X plus 4, 5x plus 3. Now you're not looking for them, like don't do any extra math to get them. Well, I'm just saying, like, we're starting to see that we'll cancel with that. That's what we're looking for. Last one is 16x squared plus 16x plus 30. Yep. So we're going to have needs to multiply to equal 16 times 3. 48. And it should add to equal 16. 48, they're both objects, so 48 would be 1 and 48. 2 and 4. Oh. 3 and 16. 4 and 7. Yeah. These we can multiply to 48 and we can add to 16. So we have 16x squared plus 3, and between those two we have plus 12x plus 4x. What can I divide out of 16x squared and 12x? 4. 4x, 16x squared divided by 4x is 4x. 12x divided by 4x is 3. And over here, 4x and 3, they don't have anything in common, but that's fine. You can just call it 1 plus 1, 4x plus 3. So 16x squared plus 16x plus 3 becomes 4x plus 3 times 4x plus 1. I'll write that up here. 4x plus 3, 4x plus 1. What is it? I did something slightly wrong. I thought it was weird that more didn't cancel. It's x minus 4 times 4x plus 3. These all have to be positive. Third is positive to be shown one positive. Okay, now it's just a matter of canceling things that are common. Sorry, canceling factors that are common to the top and the bottom. So the parentheses being multiplied, so each of these is a factor. We have 4 factors on top and 4 factors on the bottom. 4x plus 3 on the top, cancel out 4x plus 3 on the bottom, and then 5x plus 3 on the top, cancel out 5x plus 3 on the bottom. It says leave it in factored form, so this is just x minus 4 times x plus 4 on top, and x minus 2 times 4x plus 1 on the bottom. All right, and the other one is x squared over y to the 6 divided by x to the 6 divided by y to the 3rd. So just like we did the last one, what we're gonna do is we're gonna change this division to multiplication by leaving the first one the same, x squared over y to the sixth. But now we're gonna say times, and we're gonna flip this one. So this one is now y to the third over x to the sixth. Good? So it's keep, flip, change. Keep the first fraction, flip the second fraction, change the sign. Now just multiply straight across. X squared times y to the third is x squared y to the third. And then y to the sixth times x to the sixth. I guess it would make sense to put them, stack them on top of each other, right? So now you have x squared y to the third, and put them in order, x to the sixth, y to the sixth. When you are dividing the same base with exponents, you can just subtract the exponents for division. Add them for multiplication. So this is division, so we're just saying 2 and subtracting 6, 3 and subtracting 6 is one way to do it. 2 minus 6 is -4. 3 minus 6 is -3. We can't have negative exponents. We just subtract them, so there's nothing under here, right? A 1. Anything divided by 1 is itself. So we can't have negative exponents. To make those exponents positive, we are going to move them across the fraction bar. So the whole base across to the bottom of the fraction, and the exponent becomes negative. So x to the -4th over 1 becomes 1 over x to the positive 4. Y to the -3rd over 1 becomes 1 over y to the 3rd. We can see this like 5 to the power of -1 is 0.2. 1 divided by 5 to the power of 1, and 1 divided by 5 is 0.2. So the exponent becomes positive if you put it at the bottom of the fraction. Or if you don't like that, we can say, all right, we have 2 x's on the top, and we have 6 x's on the bottom. And then we have 3 y's on the top and 6 y's on the bottom. And then we just cancel them. This x cancels this x, this x cancels this x, this y cancels this y, this y cancels this y, this y cancels this y. Doesn't happen. We have 4 x's, and we have 3 y's, and we have nothing on top, but we keep a placeholder as 1. Either way, that's your answer.